Owing to our unique construction and completion process, some of Rover Maritime's works have been bestowed with the title of Special Structure. The best example of this type of Rover Maritime project is the refurbishment of the Prat Wharf at the Port of Barcelona. The morning of the 1st of January 2007, one of the biggest breakdowns in the construction of maritime works in Spain occurred. A year and a half after its construction, the structure of Barcelona's Prat Wharf began to collapse, causing the displacement up to 100 meters of 660 meters of quay line made up of 16 concrete caissons. This movement also caused much of the filling material of the reclaimed area to move and to be dispersed all over the basin. 12 months later, the Barcelona Port Authority's governing board finally approved a construction project to rehabilitate the wharf. The final cost of this came to over €82 million, and on the 31st of January 2008, Rover Maritime began the work. The work of rebuilding the affected quay line mainly involved the refloating and repairing of the caissons, the demolishing of those caissons that were not refloated, dredging in order to fill the reclaimed esplanade and dumping areas, and construction of a new wharf. The creation of the closing basin for the auxiliary dumping area, located to the south of the dock and which served as the place to dump the dredged material, was the first step in this long and arduous process of reconstruction. The caissons affected were found to have been shifted, turned around and overturned with sharp heel and trim angles, with up to 80% of the caissons silted up and limited passage through them. Furthermore, they had major structural damage and were covered by the rest of pipes and rocks. In this situation, it was necessary to refloat a total of 11 caissons, using 3 different methods to do so. Namely, direct flotation, refloating with the aid of covers and chimneys, and refloating with the aid of a low perimeter wall. The reflotation work had to follow a laborious process, involving prior inspection of the caissons by divers filming underwater, the removal of all remains of the accident, the demolition of the concrete upper slabs, the removal of the demolished material, loading onto hopper barges and transport to the dumping site, emptying the filling material inside the cells by means of suction pumps, close-up dredging of the mud in the caisson perimeter, loading onto the hopper barge and transport to the dumping area, internal inspection of the cells and external inspection of the caisson by divers, drawing up a specific project for reflotation with a newly designed group of cells and structural testing of the outer walls. Redistribution of groups of cells by sealing off communications and repairing any damage in the side walls. Reconstruction of the caisson's top to ensure it's hermetic after the covers and chimneys are placed. Positioning of the covers and chimneys, sealing the areas where covers and cell walls meet. Positioning of low impermeable perimeter walls and sealing off where they meet the caisson's face. Instrumentation and pumping of the water inside the cells. Transport of the caisson to a temporary location. And finally, once every caisson was refloated, an inspection was made of their real conditions to define the necessary repairs. The total time for refloating the 11 caissons was 1 year. Without a doubt, One of the biggest challenges facing Rover Maritime in this project was the demolition by direct impact and subsequent removal of the 5 non-refloated caissons, 4 of them due to their geometric position after the incident and 1 due to its structural damage. To this end, 2 kilometers from the demolition area, a zone was prepared to dump the demolition debris that was removed in different ways depending on its nature. Clean dredged material directly dumped on the barges, whereas large chunks of concrete were placed on a pontoon and offloaded to land by crane, where they were then sent to the waste management plant for recycling. The most relevant equipment of demolition was the dipper dredge, the largest of this kind currently available, which has a bucket of 20 cubic meters and a total power of 3,400 kilowatts. The auxiliary resources used were a 60 by 20 pontoon with a load capacity of 3,350 tons, a non-propelled hopper barge for 900 cubic meters, and a self-prepared hopper barge of 720 cubic meters in order to load the demolished material. To transport the pontoon and the hopper barge, there was a multi-cut. In addition, support equipment included 2 small dippers with hammer, cutter and milling capabilities among others. Another major difficulty that the Rover Maritime team found was in adapting the area designated for offloading the demolished materials, getting enough depth for the pontoons and fixing its anchorage points. With this aim in mind, a 350-ton lattice boom crane was positioned in the zone to take away larger materials. The demolition process began on the 10th of June 2009 and ended just 50 days later with the wrecking of the last caisson. While carrying out the work of refloating and demolishing the caissons, once the basin was clear, the various dredging tasks began. General dredging of the dock down to a depth of 16.5 meters with a total dredging volume of about 3 million cubic meters. To this purpose, the Prat Wharf area itself was used as a dumping area for the reclamation, and once it was completed, to the auxiliary dumping area that was prepared prior to the commencement of the works. Dredging Type 1. Inside and near the affected caissons down to 16 meters below sea level. Dredging Type 2. Inside and near the affected caissons, from 16 meters to 19 meters below sea level. Dredging Type 3. Key trench 25 meters wide and up to 16 meters below sea level. Once the affected caissons were demolished and refloated, the activities to build up the new quay began. Once those activities were accomplished, the structure of Barcelona's Prat Wharf was completely restored.